Okay, so now we basically we're in the situation where we have these observations of the spectral lines in hydrogen, and we have phenomenological um, models or formulas which agree with the data but don't explain why um, those mathematical relationships between the wavelengths exist. Okay, and enter um, Bohr. Okay, so if we think about it, um, at this point in the history of science, um, Rutherford's had made his hypothesis uh, of a nucleus where the positive charge and mass of an atom was concentrated, and Thomson had measured the charge and the charge to mass ratio of an electron. Okay, so that those were known, and so we knew that electrons were small, negatively charged, small in the sense that they're light and negatively charged. They have small mass. Um, and so one of the important questions of the day then was, well, how the electrons arranged around the nucleus? So again, the Thomson's plum pudding model was basically proved to be inaccurate by Rutherford's experiment and Geiger and Marsden's experiments and Rutherford's hypothesis. Um, but still, it didn't tell you how the electrons were arranged. It just said that the plum pudding model for the nucleus wasn't. I mean, for the positive charge wasn't the right atomic model. Okay, and so Niels Bohr in 1930 he proposed that since you have a very small positively charged nucleus and a very light electrons with negative charge, uh, that those two that system could be thought of as a mini planetary system with the electrons, orbiting the positively charged nucleus, and the Coulomb attraction, that is the electrostatic attraction, which was already known very well, uh, between the positively charged nucleus and the negative electrons, would play the role of gravity. Okay, so in a planetary system, in a terrestrial planetary system, right, the planets orbit, and the centripetal force which holds the planets in their orbit around the sun is provided by gravity. And Bohr said, well, we can make little planetary systems out of little solar systems uh, out of electrons and nuclei with the Coulomb attraction playing the role of gravity. Okay, and so this is sort of what it would look like. Then we have a negatively charged electron that's going around in an orbit. Okay, so again, like in an orbital, like in a planetary system, the electron's velocity is always tangential to the circular orbit. He was imagining circular orbits. The positively charged nucleus with a charge z, where z is the atomic number times the positive z times the electric charge E, okay, is at the center, and the electron goes around a circular orbit with radius r, okay, and the orbital motion here of the electron actually stabilizes it so that it doesn't crash into the nucleus, just like the orbital motion of planets stabilizes them from crashing into the sun. Okay, so we can, using this model, this simple idea, we can proceed to calculate the energies of the allowed energies of the electron in such a system, and we're going to concentrate on a single electron atom, so basically hydrogen, okay, where you have a just one electron here. We allow for the fact that the nucleus may be have a charge bigger than 1 e. So we can talk about ions, where the nucleus is not just doesn't just have a single positive charge, but multiple positive charges, but it's ionized so that we only have one electron.